Welcome to our lesson on understanding data science fundamentals. In our increasingly digital world, we're generating more data than ever before, approximately 2.5 quintillion bytes daily. But data alone isn't valuable until we can interpret it meaningfully. That's where data science comes in. This discipline combines multiple fields to extract actionable insights from raw information. During our time together, we'll explore the essential building blocks of data science, walk through the practical life cycle that turns questions into answers, and examine how visualization serves as the crucial bridge between complex data and human understanding. Whether you're just beginning your data journey or looking to strengthen your foundation, these concepts will prove invaluable. So what exactly is data science? At its core, data science is an interdisciplinary field that combines multiple domains to extract knowledge from data. As you can see in our table, it draws from statistics, which provides the mathematical foundation for analyzing data and determining the significance of our findings. Computer science contributes the programming skills and algorithmic thinking needed to process large datasets and build predictive models. Domain expertise is equally crucial. Understanding the specific field you're working in helps frame the right questions and interpret results meaningfully. For instance, data science in healthcare requires different contextual knowledge than in finance. Finally, communication skills enable data scientists to translate complex findings into clear recommendations that stakeholders can act upon. Together, these components form a powerful toolkit for transforming raw information into valuable insights that drive decision-making. When we break down data science further, we can identify 5 key pillars that form its foundation. First, data engineering focuses on the technical infrastructure necessary to handle data at scale. This includes designing efficient data pipelines and storage systems that can process terabytes or even petabytes of information. Second, data analysis involves exploring datasets to uncover patterns, relationships, and anomalies through statistical methods. This exploratory work often reveals initial insights and helps formulate hypotheses. Third, machine learning and AI extend our analytical capabilities by enabling computers to learn patterns and make predictions without explicit programming. These technologies power everything from recommendation systems to autonomous vehicles. Fourth, data visualization transforms complex findings into intuitive graphics that highlight key insights. We'll explore this crucial component more deeply throughout this course. Finally, business intelligence connects all these technical elements back to organizational goals, ensuring that our data work translates into tangible business value through strategic decision-making and measurable outcomes. Now let's examine how data science operates in practice through what we call the data science lifecycle. This iterative process begins with problem definition, clearly articulating what question we're trying to answer or what problem we're trying to solve. Without this clarity, even the most sophisticated analysis can miss the mark. Next comes data acquisition and cleaning, often the most time-consuming phase. Data scientists typically spend 60 to 80% of their time here, gathering relevant data sets and addressing quality issues like missing values or inconsistencies. The third stage involves exploration and analysis, where we begin to uncover patterns and relationships within the data, often using statistical methods to test hypotheses. In the modeling phase, we develop algorithms that can predict outcomes or classify information, carefully validating their performance against test data. Finally, deployment and communication bring our insights to life through implementation and visualization. Throughout this process, visualization plays a crucial role at each stage, from initial data exploration to the final presentation of results to stakeholders. Visualization is not merely the final step in data science. It's an essential component woven throughout the entire process. During the exploration phase, visualizations like histograms and scatter plots help data scientists quickly grasp the shape of their data, identify outliers, and understand distributions without diving into complex statistics. This visual exploration often reveals unexpected patterns that might be missed in numerical analysis alone. When analyzing relationships between variables, Techniques like correlation matrices and regression plots make complex interactions visible and interpretable. During the modeling stage, visualizations such as ROC curves and confusion matrices help evaluate model performance and guide refinements. Finally, in the communication phase, well-designed visualizations translate complex findings into clear, compelling stories that resonate with stakeholders who may lack technical expertise. Throughout this process, visualization serves dual roles: as an investigative tool for the data scientist and as a communication medium for sharing insights with others. Let's look at how data transforms from its raw state into actionable insights. This journey begins with raw data, often unstructured, messy, and overwhelming in volume. Consider a company collecting thousands of website interaction records daily. Through processing, this raw data becomes structured and usable, perhaps showing aggregated user behavior patterns. This processed data becomes information when we organize it meaningfully, such as identifying pages with high abandonment rates. As we apply context and experience, this information evolves into knowledge, understanding why users abandon those particular pages. True insights emerge when we discover specific patterns that reveal opportunities, like finding that complex forms are responsible for 68% of abandonments. Finally, these insights enable informed decisions such as redesigning those forms to improve conversion rates. Throughout this transformation, visualization acts as an accelerator, making patterns more apparent and insights more accessible. It compresses what might take hours of analysis into seconds of visual perception, dramatically speeding up our ability to move from data to decisions. Data science has transformed operations across virtually every industry, delivering measurable impact through better decision-making. In healthcare, predictive models analyze patient data to identify those at risk for readmission, enabling preventive interventions that have reduced readmission rates by up to 20% in some hospitals. Retailers leverage customer segmentation to deliver personalized experiences, significantly boosting conversion rates through tailored recommendations and marketing. The financial sector employs sophisticated algorithms that can detect fraudulent transactions in milliseconds, saving billions annually. In manufacturing, predictive maintenance uses sensor data to anticipate equipment failures before they occur, dramatically reducing costly downtime. And transportation companies optimize routes using real-time traffic and weather data, cutting fuel costs while improving delivery times. Behind each of these applications lies not just sophisticated algorithms, but also compelling visualizations that translate complex models into understandable insights. Without these visual interfaces, many of these powerful applications would remain inaccessible to the decision-makers who need them most. Despite its transformative potential, data science faces significant challenges that practitioners must navigate carefully. Data quality issues remain perhaps the most fundamental obstacle. The principle of garbage in, garbage out reminds us that even the most sophisticated algorithms cannot compensate for poor quality data. Ethical considerations have also moved to the forefront, with growing concerns about privacy and algorithmic bias that can perpetuate or amplify existing inequalities. Communication gaps between technical teams and business stakeholders often impede implementation, as valuable insights get lost in translation. Additionally, many organizations struggle with integrating data science outputs into existing processes, facing resistance to change even when the potential benefits are clear. Visualization plays a critical role in addressing several of these challenges, particularly by making data quality issues more visible and by bridging communication gaps. Well-designed visualizations can make complex concepts accessible to non-technical stakeholders, ensure transparency around potential biases, and help build the organizational consensus needed to implement data-driven changes. As we progress deeper into our course, we'll explore how thoughtful visualization can help overcome these common data science pitfalls. As we've touched on throughout this lesson, visualization serves as a critical bridge between raw data and human understanding. Our visual system has evolved to rapidly process patterns, making visualization an extraordinarily efficient way to comprehend complex information. When we visualize data, we can instantly recognize trends, clusters, and outliers that might take hours to identify through numerical analysis alone. Beyond pattern recognition, visualization democratizes access to insights by making them accessible to people without statistical or technical backgrounds. It allows us to test our assumptions quickly, seeing whether the data actually behaves as we expected. Perhaps most importantly, visualization transforms abstract numbers into concrete representations that connect viscerally with viewers, enabling not just understanding, but also persuasion and action. As the renowned statistician John Tukey noted, the greatest value of a picture is when it forces us to notice what we never expected to see. Throughout this course, we'll explore how to harness this visual power to transform data from rows and columns into compelling visual narratives that drive understanding and decision-making. Let's recap what we've covered in this introduction to data science fundamentals. We've seen how data science represents the intersection of multiple disciplines: statistics, computer science, domain expertise, and communication, working together to extract meaningful insights from data. We've walked through the data science lifecycle, from problem definition to deployment, and explored how this process transforms raw information into actionable knowledge. We've emphasized that visualization is not just the final output, but a critical tool throughout the entire process, helping us explore data, refine models, and communicate results effectively. We've examined real-world applications that demonstrate data science's transformative impact across industries, while acknowledging the challenges practitioners face in implementation. As we move forward in this course, I encourage you to reflect on your own field or projects. How might more effective visualization improve understanding and decision-making in your specific context? In our next lesson, we'll build on this foundation by exploring the power of visual communication in more detail, examining how our brains process visual information and why this matters for effective data presentation.